So we're going to take a brief look at scientific notation in a separate lesson from our exponents. So in scientific notation, a number is written with a decimal point right after the first non-zero digit number and multiplied by the power of 10. So this is often how we write very large or very small numbers. Now, what does it mean when I say a decimal point right after? So in scientific notation, we can only have one number in front of the decimal, and we could have however many numbers behind it, but we can only have one in front of it. So if you look at the two examples here, the 8.5 and the 46.5, 46.5 is not in scientific notation because there's more than one number in front of the decimal. Over here, the 0.230, that's not in scientific notation because we still have to have a number in front. So instead of writing 0.23 times 10 to the fourth, we want to write it as 2.30 times 10 to the third. So it's really important to mind that in the lab because it will mark you wrong. So to convert a positive number to scientific notation, you've got to position the decimal point. So a good idea to do this is place the caret to the right of the first non-zero digit where the decimal point will be placed. So just after the first digit. Then you're going to determine the numeral for the exponent. And you're going to do that by counting the number of digits from the decimal point to the caret. And this gives us an absolute value of an exponent on 10. Then we're going to determine the sign. So if I'm looking for an exponent that's a positive number, it's going to be a large number. If I'm looking at an exponent that's negative, it's going to be a very small number. So let's look at how to do this. In the example given, we need to place that caret directly after the 2. And then we're going to count from the existing decimal place, which is right where my arrow is, over to the caret. So 1, 2, 3, 4, 5, 6, 7. So there are 7 digits. It's going to be positive because I moved it over to the left. And it's going to be 2.98 times 10 to the 7. We do not write the zeros typically in scientific notation. We're only concerned about those non-digit numbers when we're looking behind the decimal place. And this one, let's place our caret where it needs to go, which is right after the 5. And then we're going to count our number of places or digits. It's going to be made less, so it's going to be a negative exponent. You can also remember I moved it to the right. So it would be 5.03 times 10 to the negative 8. Now, if I want to convert numbers from scientific notation over there, I'm going to take positive numbers with a positive power of 10, and those are going to become very large. Negative powers are going to become very small, and if n is 0, the decimal place is left where it is. So if we're looking at 2.51 times 10 to the third, I need to move the decimal point 3 points to the right, which would be 1, 2, 3, so 2,510. And the bottom one, I need to move it to the left 4 places. So I'm going to do that, and that would give me negative 0.00068. So you would just count here, 1, 2, 3, 4, and you would place a 0 in every loop. Now we can utilize our Web 2.0 calculator for these types of problems. So you'll be able to evaluate that completely, and it will give you the answer in your scientific notation. So the book does use some different methods to do this. We don't need to worry about that because you can definitely use your Web 2.0 to accomplish that. So here's an example of a word problem you might see in this section. The distance from the sun is given here by this large number. How long will it take a rocket traveling at that speed to reach the sun? Well, we know that distance is the rate we travel times how long we travel. So that time would be our distance divided by our rate. Now, what we can do here is we can use some basic exponent rules to help us out. 10 to the 7th divided by 10 to the 3rd would be 10 to the 7 minus 3, which is 10 to the 4th. Then I can just calculate 9.3 divided by 3.2 to get 2.9. So then it would be 2.9 times 10 to the 4th. You can also type this directly into the Web 2.0 calculator, and it will give you the right answer from there.